Hi, welcome to my last solution to the staircase problem, and in this solution I wanted to cover a combinatorics approach to solving the staircase problem. I like examples, so I'm first going to start off with a pen and pencil example before we get into the coding. So I'm going to jump down to my surface. Okay, let's start off with just a simple example that we have been using, a staircase with 5 steps, and we are talking about step options of 1 or 2. Now, when I think about this, I really have 3 major kind of cases of ways that I can climb this staircase. One way would be 5 steps of 1. Okay, so that would look something like 1, 2, 3, 4, 5. Okay, I could have another major case of 3 steps of 1, and then 1 step of length 2. And one way that I could do that would be 2 and 1, 1, 1. Okay, I could also do 1, 2, 1, 1, 1, 1, 2, 1, or 1, 1, 1, 2. And the last major case that I could do would be 1 step of 1 and 2 steps of 2. One way that I could do that would be 1, 2, 2. I could also do 2, 1, 2, or I could do 2, 2, 1. Now, for each of these cases, I have the same number of types of steps. In the first one, they're all 1s. In the second one, I have 1, 2 in each of those examples, and I have 3 1s. Okay, and for this one, I have 1 step of length 1, and I have 2 of the step lengths of 2. So for each one of these, that would just boil down to a distinguishable permutation. The first one, I have 5 total objects. That would be 5 factorial. I only have 1 type of distinguishable object, so that would be divided by 5 factorial. That would give me one way. Okay. In the next case, I have 1, 2, 3, 4 total objects, so that would be 4 factorial. I have 2 distinguishable types of objects. The first one I just have 1 of, so that would be 1 factorial. The second type I have 3 of, so that would be 3 factorial. And then that would boil down to just 4. Okay, 4 ways. 1, 2, 3, 4. For the third case, I have 1, 2, 3 total objects. Of the first type, I just have 1, so 1 factorial. The second type, I have 2 of them, so that would be 2 factorial. Okay, and that would give me 3. 1 plus 4 is 5, plus 3, that gives us our 8 ways. Okay, and this is going to be the basic gist of how we do the combinatorics approach to solving the staircase problem. Obviously, we could have any length of staircase, and I can have any sort of combination of different step options. The only thing that we need to worry about up to this point is how to determine these larger cases. So I'm going to continue here, and I'm going to show you an example of how I'm actually going to come up with these larger cases. Okay, so new sheet of paper. So here, just to remind ourselves, we had a staircase of length 5, and we're dealing with step options of 1 and 2. Okay, I'm going to create sort of a table here, and along the top, I will have our step options. And one thing I want to add here is sort of a max of each of these options. Okay, so I have my step lengths of 1, my step lengths of 2. The maximum numbers of step length of 1 I could do would be 5. For step lengths of 2, the max number of steps of length 2 I could take for staircase of length 5 would be 2. Okay. Now what I'm going to do here is I want to iterate down the different sort of options. So the base case that I could do, I could have 0 of length 1, 0 of length 2. I could do 1 of 1, 0 of 2, and just continuing this on, I would do 2, 0, 3, 0, 4, 0, 5, 0. Okay, I'm going to pause here and note that each one of these sort of step combinations here have a particular length, which not all of them are going to get me to the top of my staircase. The first one would be 0. This would be 1, 2, 3, 4, 5. Okay, I'm going to move over here and continue this. So this is for my step length 1, my step length 2. I can do a maximum of 5 of 1, a maximum of 2 for the 2, and we'll also be considering the length of each of these combinations. Now here for this first one, I got up to 5 of 1, but that's the maximum I can do for for step length of 1. So just somewhat like counting, I'm going to crash my 1s to 0, and I'm going to increase my 2s by just 1, and then I can continue on counting. 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, and then each one of these has a length. So the first one, I have 1 of my step length of 2, so that would be 2, and then I'm just increasing by 1 down there. So that would be 3, 4, 5, 6, 7. And then I'm going to continue this on. So I'm going to again crash my 1s to 0, and then I'm going to increase my 2s by 1, so that would be 2, and then I'll just continue this on. So 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, and then each one of these has a particular length. We'll start with 4, and then we'll have 5, 6, 7, 8, 9. Okay. Now, as I'm doing this sort of counting of my different step combinations, what we're interested in is reaching the top of our staircase. So I'll take special note of when my length was 5. Okay, and that gave us that can kind of give us an ordered pair of the different step combinations that will reach us to the top of our staircase. So the first one, I'm going to do 5, 0, and then here this ordered pair, I would consider the first one to represent my step length of 1, and the second one to represent my step length of 2. I would have 3, 1, and then finally 1, 2. And then each one of these can give me sort of a result of my distinguishable permutation. So this one would be 5 factorial over 5 factorial. This one would be our 4 factorial, our 4 total objects, and then divided by 3 factorial, 1 factorial. And then the last one, 3 total objects, 1 factorial, 2 factorial. And then each one of these, just like before, gives us a certain number of ways. This one totaling us up to 8 ways. Okay. Now I'm going to leave you with kind of an example to do on your own. So in this example, I want you to do on your own. We're still going to have a staircase of length 5, but I want you to work out if you had step options of 1, 2, and 3. Okay, so here you'll have an extra column kind of in this area, and then you'll need to compute the different maximum of each of those step options. Okay, and then find out what the different possible step combinations were, and work out what those distinguishable permutation results would be. So at this point, pause the video, and then we'll come back and I'll show you what I came up with. Okay, so hurry up. Okay, 5, 4, 3, 2, 1, and then here are the results of that. Okay, so here I came up with 1, 2, 3, 4, 5 different possible step combinations. I worked out their distinguishable permutation results, and I got a total of 13 ways. Again, just like before, I really encourage you to try to work this example out on your own. Even if you've seen this part, pause the video, work it out. Maybe pause this on the screen so you can look. But this will really help when determining when we actually code the algorithm. The only thing that I really want to note here, I've kind of boxed it in, is this 12. Okay, and that was kind of the maximum length that we can achieve when we hit all the maximum. I'm going to use that as a stopping point, so I know that I can stop iterating through all of these different step combinations, looking for the ones that actually brought me to the length of my staircase. Okay, so we're going to go ahead and code this, okay, or at least start coding it. Okay, let's jump into this. I've already set up a Python file, and let's get going. So the example I want to use while we're coding this is staircase of length 5, and let's do a step list like the second example that we did. So that's step length of 1, 2, and 3. Let's set up a function, climb stairs. We'll pass it our staircase length as well as our step list, and we'll go from there. So def climb stairs, staircase length as well as our step list. And the first thing that I said that we want to do is we want to note the maximum of each of our step length options that we can do. So we'll set up another function to do that. So let's def, and let's do get max of each step. And there we'll pass it our staircase length as well as our step list. And this is going to be a little interesting to do, because we're using a function that, at least in Python, I'm not quite sure if it's in other programming languages. It'd be interesting to find out. So let's make a list. So max of each step. We'll just make that empty for now. And then for each step length in our step list, I'm going to append to our max of each step. I'm going to append to it n divided by our step length. Now this divided, what it will do is it will truncate any sort of result. So in this case, we have 5. We're going to divide it by 2 and 3. Those don't go in evenly into 5. But when I do 2, 2 can only go into 5 a maximum of 2 times. I'll have some little left over, and it will go ahead and truncate that. Okay. So let's go and let's return our max of each step length, inside our kind of climb stairs a function here. Let's first just print out this function, the result of our function, pass it our staircase length, as well as our step list. Okay. And then we'll go from there. So Python, and I called this step Combinatorics, py. Oh, what did we do? Step length. Didn't spell things right. There we go. Okay, so this is our max of each step length. We can take a maximum of 5 of our step length of 1, 2 of our step length of 2, and 1 of our step length of 3. Perfect. Okay, and then in our kind of master function here, we'll just call that our max of each step. I wanted to put that in a function just to get it out of the way. Okay, now what I want to be able to do is I want to calculate the length of any sort of step combination that we would be doing. So let's do def get length of step combination. And there I'll just pass it our step list, and then here I'm just going to pass it a step combination. So I'm going to do print, we'll do get length of our step combination. We'll pass it our step list as well as a step combination. And let's set up a dummy step combination to pass it, and we'll just call it 1, 1, 1. Okay? Now here what I will return, first what I want to do is show you this little trick here. So we'll print out, and I want to zip my step list with the step combination. And then we'll go ahead and return 1 to this combination. So for this print, it'll just print out 1. Okay, so we'll save that. Let's run that. What did I do there? I have, there we go. Now it should be okay. Okay, so this zip here, so my step list was 1, 2, 3. That's the first element in these ordered pairs. And then my step combination was my 1, 1, 1. So that's the second element in these ordered pairs here. Okay, so what I want to do here is I want to do a list comprehension. And I'm going to say we're going to have x times y for x comma y, these ordered pairs, in my step comment or my zip. Okay, we can print that again to see what we get. Okay, so here I got 1, 2, 2, 3. 1 times 1 is 1, 2 times 1 is 2, 3 times 1 is 3. Surprise, surprise. Let's change that up just a bit. We'll do 2, 2, 2, just to make sure that that's working correctly. So 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. Perfect. Okay? And then the last thing I want to do here is I want to sum those up, because what I'm interested in here is the length. So 2 plus 4 is 6, plus 6 is 12. Good, 12. And really what I want to do is I want to return this sum. So I will return the sum. And so here I shouldn't see this 1 anymore. I should just see 12. Great. Okay, so now I can get rid of this. And what I want to do here is I'm going to note my max length combination. Okay, and I'm going to set that equal to, or I'm going to pass it my step list, and for my step combination, what I'm going to pass it is my max of each step. Okay, so that should be the maximum length that any combination could do. And we'll go ahead and print that out, see if that makes sense. Max length combination. Oh, probably have an extra parenthesis. I do. And that was 12. 1 times 5 is 5. 2 times 4 is 4. So that gives us 9. Plus 3 gives us 12. So that is working out. Now what I want to do is I want to iterate over all of those kind of step combinations. Okay. So for here, what I'm going to do is pause the video so I can think. Okay, now that we have our max step length, we can get rid of this print and we can start working on iterating through all of our step combinations. So let's first set up that step combination. I'm going to start it off first as length 0, because I'm not necessarily going to know how many step options that are going to be passed to this function. And I'm going to immediately start to take advantage of that max length combination. What I'm going to be using that for is to tell once I'm done iterating through all of our possible step combinations. So I'll get the length of the step combination, we'll pass it the step list as well as the step combination. And I want to run this until this is until it is not equal to our max length combination that we just calculated. Okay, and then here let's set a step combination equal to, and we're going to create a new function, get next combination. So we'll pass it a step combination as well as our max of each step. Okay, we'll set up this function, get next, and we have the step combination and our max of each step. Now, first time this function is run, our step combination will be of length 0, and we'll take advantage of that. So length step combination, if that is equal to 0, then we'll want to populate it. For let's do each max step in max of each step. For how many ever max of each steps there are, which matches the number of step length options that we have, I'm going to append to our step combination just 0. Okay? And then at the end of all of this, we will return our step combination. Now, for any other time that I've run this function, it will not have a length of 0. And this is where we're going to do all of our business. So we'll iterate for I in range, and we'll go ahead and go from 0 to the length of our step combination. And the first thing that we want to do is we'll test. Okay, I'm going to try to put my first increase in our I, but I don't want to do that if we've already reached the max capacity for that location. So if our step combination, if what we have at indice I, if that I only want to do this if it is less than our max of each step in that same location. Okay, so if it's less than that, then what I want to do is increase it. So it'll be equal to step combination at that location, and we're going to be adding to it 1. Okay, and if I did that, that means that is my next step combination, so I will go ahead and return it my step combination. Okay. And then if not, what it will do is it will kick over to the next location in there. So let's go ahead and we will print out our step combination down here, and hold on to your butts, and let's see if this works out. Okay, I think that actually did not work. So what did that do there that did not work? I made a mistake. So if up here, if this is not true, what I needed to do here is I needed to set my step combination at location 0, or that particular indice equal to 0 before we move on. Now it should work. There we go. That seems like it worked out better. Okay, so here, as you can see, I went 0, 1, 2, 3, 4, 5. Then I increased it. Then again, I went through 1, 2, 3, 4, 5. Then we increased it. Again, then when we increased it, and we went all the way up till we hit that maximum of each one of our step length options. Okay, now we'll go down here into our loop, and I want to change this print here. Okay, so I'm going to do an if our, well, you just copy this, because here I wanted to test the length of my step combination. So if that, the length of my step combination, if it is equal to n, our step or staircase length, then we will print it out. So if, does that match up? Yep. Then we will print out our step combination. And we should only get a list of 5. Oh. What didn't it like there? Oh, it needs to be equal, equal. There we go. So those were our, I'm just going to make sure that those were the ones that we should get, and they are. So the only thing that we need to do now is calculate our binomial coefficients, multinomial coefficients, and sum them up. But this video is already going to be pretty long, so I'm going to cut it here. Anyways, until next time, bye.